this video, we're going to solve exponential equations using some logarithm properties and the idea of logarithms to undo exponent operations. All right, so the first thing I want you to remember is we have the rule that says the log base b of m equals x. We can translate that or transform that into b to the x equals m. Okay, and we're going to use this idea to help us solve these exponential equations. All right, so in this first example here, I've got 5 to the x equals 92. Now we know that 5 squared is 25, and we know 5 to the 3 is going to be 125. So I know my answer for x is going to be somewhere between 2 and 3, and then it will be a decimal value. But here's how we're going to find that. So if I use my logarithm property here, okay, I can go from this right side and can convert it back to this left side. And that would look like log base 5 of 92 equals x. All right, so that's one way to think about it, is using that logarithm property to do it. The other thing, we're going to use a similar idea, but a different way to get to the same spot is I can say, okay, well, if I just take log base 5 of both sides, right, I've done the same operation on both sides, so I've stayed balanced in my equation. On this right side, I have log base 5 of 92. And on the left side, log base 5 of 5, it just undoes itself. Okay, they're opposite operations there. That's just going to leave me with an x. So either way, I get the same spot, but two different ways to think about that. And from here, we're going to use our calculator to figure that out. Okay, and we're simply just going to type log base 5 of 92. And that's going to give me an x value equal to roughly 2.8095. All right, the next example is going to be the same exact thing, but now it's a little bit different. I have this value out in front, okay? And before I can apply any of my logarithm rules or properties, I've got to make it so that all I have is a base and an exponent on one side. So I'm going to follow normal equation solving rules that I would do to simplify it. I'm just going to divide both sides by 6. That's going to give me 4 to the x is going to equal 43. And again, using all of my logarithm rules, I'm going to take the log base 4 of both sides. So those are opposite operations, cancel out. I have x equal log base 4 of 43. And again, I can use my calculator to help me out here. I'm going to type that in as log base 4 of 43. And that is going to give me roughly 2.7131. All right. All right, let's go look at the next example. It's the same idea here, right? Except now I have that natural number e, all right? And if you'll remember back a few videos, you'll remember this one right here. This rule here, I have e to the x equals m can be translated to the natural log of m equals x, okay? So that's kind of a rule you can use. If we do that, that will translate to natural log of 17 equals t. Or you can think about it like this. You can say, all right, I'm just going to take the natural log of both sides. So I have the natural log of 17 on the right side, and then right here, the natural log and the e are opposite operations of each other. I'm just left with the t. Again, I'm going to use my calculator, type in the natural log of 17, and I'm going to get t equals roughly 2.8332. Okay? All right, let's go look at the next one. Very similar to the other one we did, right? I've got this 2 value right here, and that is going to, so I have this 2 value here, and I've got to do something with that first. Again, normal equation solving rules. I'm divide each side by 2. Those 2's turn into 1. You're left with e to the n equals 18. And then from here, I'm going to take the natural log of both sides. So I have the natural log of 18 over on the right, the natural log and the e are opposite operations. I'm left with just the n value. And then I'm going to use my calculator to type that in. And I'm going to get roughly n equal to 2.8904. All right. All right. 2 more examples here. This one's a little bit different. So now in my exponent, instead of just having a variable, I have an expression up there, but I'm still going to follow the same exact rules, right? I have the unknown value up here in the exponent, so I'm going to take the log base 2 of both sides, Okay, and the reason I do that is because the log base 2 and the 2, those are opposite operations, and they cancel each other out. I got 3x minus 2 over on the right, and I've got log base 2 of 32. Okay, so now if I look at this expression here, I'm going to do a little side work. I can say I have the log base 2 of 32. Using some logarithm rules I already know, 2 to what power equals 32? And I know that that power is going to be 5 to the 5th equals 32. So I can simply replace this expression here with a 5. So I've got 5 equals 3x minus 2. And from here I can add 2 to both sides and just solve this like a regular equation. I get an x equal to 7/3. Okay, now we'll come over here and look at our last example. Okay, very similar to the one we just did. I have an expression here in the exponent, so I'm still going to take the log base 4 of both sides, and I do that because those are opposite operations, cancel each other out. I got x minus 1 equals log base 4 of 40. But now this one is not so nice to us. Okay, it gives us kind of a long decimal there. I don't 4 to what power gives me 40. I know that that's going to be a decimal value, right? Because 4 squared is 16, 4 to the third is 64. So I'm going to have some number that's in between 3 and 4, and that's okay because I do know this is going to give me a value. It's going to give me a number. It's just going to be an irrational number. And I'm going to use my calculator here in the end to figure that out. But I'm going to go back to my equation. I'm going to solve it just like normal. I'm going to add 1. I'm going to add 1 to both sides, and remember, make sure you put that log base 4 of 40 in parentheses if you type it in the calculator so it knows that we're only doing log base 4 of 40, and then whatever that number is, we're going to add 1 to that. So that gives me x equals, and now I'm going to go use my calculator to calculate that. I have log base 4 of 40, and then I'm going to add 1 at the very end, and that's going to give me roughly 3.6610. All right, I hope this video helps. Remember, sometimes you might need to use that calculator to figure out logs when they give you irrational numbers. Sometimes those logs will give you integers or whole numbers for us to work with. Okay, so just pay close attention to that. Remember this rule, and good luck in solving exponential equations. Hope this video helps, and I'll see you in the next one.